In this lesson, we're going to explore the creative and inventive techniques that Elon Musk uses to solve some of the world's most complex problems. We'll examine first principles thinking, his 5-step design process, the Socratic method, systems integration, rapid iteration, and open source philosophy. Let's start with first principles thinking. This is perhaps Musk's most powerful mental tool. First principles thinking means breaking a problem down to its most fundamental truths and reasoning up from there. Instead of reasoning by analogy, you question every assumption. Most people reason by analogy. They look at what others are doing and make small improvements. But this limits innovation because you're constrained by existing solutions. Musk constantly asks, what are the actual physics of the problem? What do we know to be true at the most fundamental level? Let me give you a concrete example. When Musk was developing electric vehicles, everyone said batteries were too expensive and would always be too expensive. The industry standard at the time was about $600 per kilowatt hour. Everyone accepted this as a fact. But Musk asked a different question. What are batteries actually made of? What are the fundamental materials? He broke it down to cobalt, nickel, aluminum, carbon, and polymers. When we look at the raw material costs on the London Metal Exchange, it's only about $80 per kilowatt hour. So the question becomes, why is there such a huge difference between $80 and $600? The answer is manufacturing inefficiency, supply chain markups, and profit margins. So Musk said, if we can build the factory right, we can get much closer to the raw material cost. This represents an 86.7% potential cost reduction. This insight led to the Gigafactory, which has driven battery costs down dramatically. Now let's look at Musk's 5-step design process. This is his systematic approach to engineering and manufacturing. Step 1. Make your requirements less dumb. Musk says every requirement should come with a name attached. If you can't name the person who made the requirement, it's probably not a good requirement. You must question every requirement, especially if it comes from a smart person. Smart people are the most dangerous because you're less likely to question them. Step 2. Try to delete the part or process. If you're not occasionally adding things back in, you're not deleting enough. The most common mistake is optimizing something that shouldn't exist in the first place. Delete before you optimize. Step 3. Simplify and optimize, but only after you've completed steps 1 and 2. The most common error is doing this step first. Step 4. Accelerate cycle time. Everyone can go faster than they think, but only after you've simplified. Don't speed up something that shouldn't exist. Step 5. Automate. This is the last step. Musk learned this the hard way at Tesla when he tried to over-automate too early. The robots couldn't handle all the complexity. Let's see how this works with SpaceX's Starship. Initially, the design had thousands of parts and complex manufacturing. By applying the 5-step process, they eliminated entire subsystems, simplified the structure, and made it much easier to manufacture. They went from roughly 10,000 parts to about 2,000 parts. That's an 80% reduction in complexity. The third technique is the Socratic method and fearless inquiry. Musk constantly asks questions and challenges assumptions. He constantly asks, why are we doing it this way? What's the fundamental reason? He never accepts tradition or authority as a valid reason. Just because something has always been done a certain way doesn't mean it's the right way. Consider rocket reusability. For decades, the entire aerospace industry said it was impossible or impractical. Musk asked, why do we throw away rockets? You don't throw away airplanes after one flight. What's fundamentally different? The answer was, nothing fundamental prevents it. It's just hard engineering, but hard doesn't mean impossible. He asked another question. What's the actual cost breakdown of a rocket? The fuel cost for a Falcon 9 is only about $200,000. But the total cost of the rocket is about $60 million. That means fuel is only 0.33% of the total cost. This is like throwing away a 747 after every flight because you used up the fuel. By asking the simple question and not accepting the industry consensus, Musk revolutionized space travel. The fourth technique is systems integration. Musk thinks in terms of entire systems, not individual components. Most companies optimize individual parts or subsystems, but this can lead to suboptimal overall performance. Musk optimizes the entire system from end to end. He looks at how everything works together. Look at Tesla. Most car companies buy batteries, motors, and software from suppliers. They just assemble components. Traditional automakers buy these components from different suppliers. Each is optimized independently. Tesla designs the battery, motor, and software together as one integrated system. This allows for much better optimization. The result is higher efficiency, better performance, and lower costs. The whole is greater than the sum of the parts. SpaceX does the same thing. They manufacture about 80% of their rocket components in-house. This allows rapid iteration, tight cost control, and the ability to optimize the entire system. They're not waiting for suppliers. The fifth technique is rapid iteration and embracing failure. Musk has a very different relationship with failure than most people. In traditional aerospace, companies spend years analyzing and simulating before they build a single prototype. They try to avoid failure at all costs. Musk's approach is completely different. Build something, test it, let it fail, learn from the failure, and iterate quickly. Look at Starship development. SpaceX has blown up multiple prototypes. Each one taught them something valuable. Serial numbers 8, 9, 10, and others crashed, but each crash provided data. By SN15, they achieved a successful landing. You might ask, isn't this wasteful? Aren't you throwing away millions of dollars? The answer is no. The cost of building and testing prototypes is far less than the cost of years of analysis and simulation that might miss critical issues. A traditional development program might take 10 years at $500 million per year. That's $5 billion. SpaceX can do it in 3 years at $200 million per year through rapid iteration. That's $600 million. That's a savings of $4.4 billion in 7 years of time. The rapid iteration approach is actually far more efficient. The key insight is that failures are not setbacks, they're data points. Each failure teaches you something you couldn't learn any other way. The sixth technique is the open source philosophy. Musk has a unique approach to intellectual property and sharing knowledge. In 2014, Musk announced that Tesla would not initiate patent lawsuits against anyone who uses their technology in good faith. You might ask, why would you give away your competitive advantage? Doesn't this hurt Tesla? Musk's reasoning is brilliant. Tesla's biggest threat isn't other electric car companies. It's the fact that 98% of cars sold are still gasoline-powered. If sharing patents helps grow the electric vehicle market from 2% to 25%, Tesla benefits even if their market share decreases slightly. It's better to have 15% of a 25% EV market than 40% of a 2% EV market. The former is almost twice as large. There are other benefits too. By open sourcing patents, you encourage standardization, you attract talent who want to work on open technology, and you accelerate the entire industry's progress. SpaceX has also shared technical details about rocket landing and reusability. This raises the bar for the entire industry. Musk regularly publishes technical papers, gives detailed presentations, and shares engineering knowledge. This seems counterintuitive for a competitive business, but it attracts the best engineers, scientists, and partners who want to work on the cutting edge with someone who shares knowledge freely. Now let's look at how these techniques work together in a real scenario. Consider the Tesla Model 3 production ramp. This combined all 6 techniques. First principles thinking was applied to every manufacturing step. Why do we need this part? Why does it take this long? The 5-step process eliminated entire subsystems, simplified assembly, and optimized the remaining processes. The Socratic method challenged industry assumptions about production rates and automation levels. Systems integration meant designing the battery pack, drive unit, and software as one unified system. Rapid iteration meant they made changes weekly, learned from failures, and continuously improved. And aspects of the open source philosophy helped them work better with suppliers and the broader industry. The result? They went from what Musk called production hell in 2017 to producing hundreds of thousands of cars per year. They went from about 300 cars per week to over 7,000 cars per week. That's more than a 20-fold increase in just 2 years. Let me summarize the key lessons you can apply from Musk's techniques. Lesson 1. Always question fundamental assumptions. Don't accept things just because that's how they've always been done. Lesson 2. Delete before you optimize. The best part is no part. The best process is no process. Lesson 3. Think in terms of complete systems, not individual components. Optimize the whole, not the parts. Lesson 4. Embrace failure as a powerful learning tool. Fail fast, learn faster. Lesson 5. Sometimes sharing knowledge and growing the entire field benefits you more than hoarding secrets. Let me show you the mathematical foundation behind rapid iteration. Your learning rate equals the change in knowledge divided by the change in time. The traditional approach does few iterations over a long time. Let's say 5 iterations over 10 years. That's 0.5 iterations per year. Very slow learning. Musk's approach does many iterations quickly. Let's say 50 iterations over 3 years. That's 16.7 iterations per year. That's more than 30 times faster learning. This gives you a 33-fold speed advantage in learning and improvement. This is the mathematical reason why SpaceX and Tesla can move so much faster than traditional companies. It's not magic, it's just math. And there's a compounding effect. Each iteration builds on previous learning. Your knowledge grows exponentially with each iteration. K0 times 1 plus r to the power of n, where r is the learning rate per iteration and n is the number of iterations. This means that more iterations doesn't just give you linearly more knowledge. It gives you exponentially more knowledge through compounding. These techniques aren't just for rockets and cars. They apply to any complex problem. In software development, iterate rapidly and delete unnecessary code. The best code is no code. In business strategy, question every process and requirement. Use first principles. In personal projects, embrace failure as rapid learning. Test your ideas quickly. In scientific research, share your findings to accelerate the entire field's progress. Let me give you a final summary of all 6 techniques. First principles thinking breaks problems down to fundamental truths and reasons up from there. The 5-step process. Question requirements. Delete parts. Simplify. Accelerate, then automate in that order. The Socratic method and fearless inquiry means questioning everything, especially accepted wisdom. Systems integration optimizes entire systems rather than individual components. Rapid iteration means building, testing, failing, and learning as quickly as possible. Open source philosophy shares knowledge to grow the entire field and attract the best talent. Together, these techniques have enabled achievements that most people said were impossible: reusable rockets, affordable electric cars, and rapid innovation at scale.